Hello, everybody. Today I'm delighted to be with with Dr. Elnasser Abdelwahab. Dr. Elnasser is graduated from the Faculty of Jeddah Computer in the Department of Computer Engineering, and he earned two masters, one from the University of Grenoble in the specialization of artificial intelligence, and the second master's was from the University of Karlsruhe in Germany, and finally he got his PhD from the University of Gießen. Welcome, sir, to my humble podcast. And Dr. Nasser is special because he combines between the computer science and the philosophy of science, epistemology, and the classical Muslim sciences. So, how did you reach this formula? Yeah.
My background is
Tell us more.
technical. Yeah. So thank you very much, Ahmed, for this. I'm honored to be with you. Actually, I'm very happy about this. So my background is more technical, and computer science, as you know, is related to mathematics, but it's also related to philosophy of science. The new achievements of in the field of formal systems, for example, has changed the world a lot. Of course, we are speaking now together through a computing device, which comes from these studies and this type of scientific endeavors. So in the beginning, I was just focused on my computer science, computer engineering. As you said, first I studied engineering, and then I went over to study the science itself in France, Grenoble, and then
I would like to excuse you. I have to open the door just a second.
Yeah, please.
Sorry, excuse me.
Yeah. So of course, my background is a little diverse. There is the part literature. I am fond of literature. I'm poet myself. I have some published poetry in Arabic, in German, and so on. But also Islamic studies, because in my family, my mother was the first lady student in the history of Damascus University
in Syria,
in the Sharia faculty. So I just got actually all these Islamic sciences in the milk, if you would like to know. So I was always fond of my Islamic background, and when I went more and more in the depth of computer science, mathematics, and so on, in the same time reading especially ancient or classical works of Arabic and Islamic philosophy, like Imam Ghazali. For some time, I am until now a very big fan of him. I have all his books. You need to make an effort to dig inside these books and get what the scientific discussions were all about, and you will find after some time that it is very similar to what people encountered in Western. I think I have here a problem with
the camera.
The camera, yeah.
Yeah, it was stable.
Yeah, I don't know why. Just let me fix it. Try to fix it.
Yeah, it's okay now.
Okay.
I think our viewers will understand more if we start the presentation.
Yeah, let me start directly.
Yeah. So
maybe better. Yeah, let me start directly.
Yeah.
So the Uh, do you get it?
Yeah. Formal systems of fiqh.
Okay, so all this has at the end made me um, try to study, try to formulate whatever I understood from my fiqh. I studied also fiqh, I must say this. I studied fiqh for 3 years on an undergraduate level, but a very detailed level with some classical usul guys,
Traditional scholars, yeah.
traditional
Who are
scholars.
trained in the tradition, yeah.
Yeah, and so out of this came the idea of reformalizing the fiqh and usul in a way which is more appropriate in our age. Of course, formal systems are the necessary condition for any science today. The formalization means that
For,
you have a
for, for, for our viewers, that for usul al-fiqh, it's the science to systemize the methods of understanding the sources of Islam. Yeah.
Actually, we can say that this is in any science there is always a trend to formalize your theories, to formalize your sentences, to make your sentences, your assertions more precise. So
Yeah.
with time, you are forced actually in physics, for example, you are forced to find your own precise descriptions of all the entities which you are studying, like electrons, protons, and so on, molecules, and so on. So you are
Mm.
forced to formalize, to make it more formal, to make it more uh,
Disciplined and organized as well.
organized, and to make it more precise.
Mm.
When I use a word, I mean exactly this and that. So this was actually I started this maybe more than 25 years ago with some friends, who is also my esteemed mother,
Mm.
and it has developed since then until it reached the level of programming.
Mm.
So let me just start directly with what I want to say. Of course, I had a motivation slide why
Mm.
I'm doing it. I don't think we need to go through it very much detail, but maybe one
Maybe
point,
maybe in the next parts we can, yeah.
maybe yes.
Yeah.
So there is a lot of noise around Islam today, and in the same time, Islam is expanding and is in need of new ways to view its heritage and so on. So all this was the motivation why I went through this
Yeah.
work.
And how formal systems would help us uh,
Yeah,
in the IT and so on to to will serve the tradition and the Islamic sciences in general. Yeah.
yeah. Actually, formal systems help us first formalize, make our assertions more precise. It
Mm.
helps us make our ideas about any phenomenon, whether it is a religion or something else, more precise, and discuss it in a more symbol-oriented way rather than in a loose natural language way.
Mm.
So what I'm going to speak about is actually first the difference between science and pseudoscience, because it's very important. In my life, I found out that a lot of confusion about uh, Islam and also about the technical matters in my own computer science or mathematics comes from this misunderstanding of what a scientific way of dealing with things is, in contrast to what they usually call pseudoscience. So I will be speaking about science and pseudoscience, demarcation criteria, causality, and determinism, objections to falsification, which was articulated by Quine, and then levels of cognitive certainty. And then we'll be having a working example which simplifies what I mean by all this. And we'll speak about basic cognitive terminology, in math and in physics, and then we'll have take a glimpse about formal systems in math, physics, and language. You might ask, for example, okay, we understand that mathematical logics and physics can be expressed in form of a formal system, but what about language? Actually, until Chomsky, the idea was that you cannot express natural language as a formal system, but this has changed now. So
for our viewers, Dr. Elnasser has an important contribution to this point. We will elaborate it further in.
We'll come to it. We'll come to, but
we'll
it is
come to it
actually, this contribution is actually only inside the framework of this project. Actually, this is not a project. It's actually more or less a set of projects which have evolved with time. We'll speak also about incapability principles in modern epistemology. And this is important to know that the idea that science is unbounded and unlimited and has no ceiling was actually, until the mid of the 20th century, was actually there. People really thought that they can one day solve everything, solve any question which comes out. But especially through the work around and for the formal systems of math and mathematical logics, we were able to understand the importance of our limitation. Actually, in computer science, as a student, most of the things which you learn, you find difficult, is related to your incapability. It's much more difficult to understand why we are not capable really of solving a problem than to find an algorithm to solve it. Much more difficult. So this is known. And so when you are in the first or second semester, even in Germany, for example, you need to know many theorems about what we cannot do with mathematical logics, or what we cannot do with
its limitations
in general. At the same time, physics, of course, physics has been working with incapability all the time from the beginning, actually. But there were always models, like, for example, Newton's first law. This is a law which has no proof. It is just an assumption, an hypothesis. But why is this hypothesis still there? And we can speak very openly of Newtonian laws as reliable science, because there is no experiment which falsifies it. So although we don't have a proof for the law or for the principle in physics, we take it as a hypothesis and build our models. And this is also important to know in the context of the demarcation between science and pseudoscience. I'll be also speaking about cognitive problems which arise around our incapability. Of course, if you start with the idea, I want science to explain everything, and then you find out, oh my God, it doesn't explain really. Actually, there are many things which it doesn't explain. Then you have to see what are you going to do with the rest? What are you going to do with all those undecidable problems which you cannot reach? Then I will be giving pseudoscience example, and here I come to religion for the first time. And the first thing I want to express through this lecture, this series of lectures with you, is that we can very simply, in a very simple way, map current Western theories about religion to pseudoscience. Unfortunately, it's not a good thing that I'm saying, but unfortunately, there has been a lot of pseudoscientific way of thinking in this area of Western theories about religion, not only about Islam, but about religion in general. Of course, when it comes to Islam, you find all the bias against the Islamic ideas and so on. So it makes this situation worse. So there are a lot of examples. Of course, there are also positive sides. There are some contributions of so-called Western Islamic studies, some real contributions to our understanding
Yeah.
of
Preserving manuscripts, editing manuscripts, and so
yeah,
on.
exactly. But unfortunately, there are also very bad ideas, very wrong ideas,
Yeah.
disguised as science, and they are actually pseudoscience. We are going to see it.
Okay.
Then we have a summary of epistemological results. So this is the idea. In the second part, I'm going to go to dig into the formal systems of Muslims as they did it historically, and then my new perspective of how I translated some of the fiqh problems into logics, and then programmed it even, so that at the end I can, inshallah, show a demo of the programs which already exist, which where you can ask a fiqh question and you will get an automatic answer. So I guess this is maybe. Can we go one
Yeah.
further?
Yeah. Do
Yeah.
more. Yeah.
How much time do we have now?
Still, we have, I think, more than 20 minutes. Yeah.
Oh, that's fine. Then we can cover maybe. Let's start by the first topic, the demarcation criteria. Now, this is classical. Actually, anyone listening to this lecture can go and find out. Even in Wikipedia, it is discussed and explained very nicely. So by demarcation criteria, we mean the line which is something like a mark between science and pseudoscience, where the question was, where does science begin, and where we can say from this moment we have science, and before that it was not science. Now, this is a question which I'm tackling here because I hear a lot of nonsense, even from Muslims, who think the ancient Islamic sciences are not sciences, who think those were only pseudosciences. Through this lecture, I hope that I will convince anyone that this is not the case. Actually, Islamic sciences are more epistemologically like natural sciences than theoretical sciences, but they are sciences. They are, for sure, they are sciences. They are not pseudosciences. Now, the demarcation criteria as per Popper, Karl Popper, first you will have, for a science to be a science, there must exist an empirical body of data. You should have empirical body of data, and with empirical we mean data coming from experiments. So you should have something like an experimental way of doing things. The phenomenon which you are supposed to study, you should have defined some experiments to know properties of this phenomenon, or to understand more or less the happenings throughout your study. So you need to have an empirical body of data. So without empirical body of data, as per Karl Popper, you cannot say that this is natural science. Of course, he's speaking about natural science. Yeah. So for him, a science is natural if you have an empirical body of data. If you have a falsification method, and for him, this is the most important criterion. This is the most important demarcation
The
line.
principle of falsifiability.
Exactly, the principle of falsification or falsifiability. And he brings in his seminal work a very interesting example, which we are going to see in detail. He says, for example, that Freud's work was not, most of the theories of psychoanalysis and so on are actually pseudo-scientific. And he gives an example about this, especially because you can never falsify you don't have a clear way of falsification of what it is claimed. We will see the example in detail. So it's not verification for Popper, but falsification. For him, an experiment does not verify the theory. It is an attempt to falsify it. So if I, for example, if giving a very simple example, if I have the idea that around the equator, the rays of sun are much more than somewhere else. What I will do is to go there and make an experiment to see whether compare between the amount of rays assembled in around the equator and somewhere else. And so if I don't, if I find that it's true that it fulfills my original hypothesis or idea, I cannot say that I verified my theorem. I can only say that the theorem was not falsified. So
he gave the example of the swans, the white swans and black swans.
Yes, also there is another example, but I don't want to go into detail because we are going to repeat it again. So this falsification is important, and the difference between falsification and verification is exactly the difference between what he was saying and what the Vienna Circle people, the positivists, were saying. So actually, for the positivists, no, an experiment verifies a theorem which Popper rejects very much, of course. And he's right in doing it because, of course, the experiments are actually incomplete induction from the point of philosophy. I mean, from the point of view inference, it's not a deductive proof. It is a proof by doing an experiment, but you could have an infinite number of experiments which are required to say
and sometimes sometimes it's impossible to do an experiment.
No, not sometimes. All the time it is impossible.
No, so, I mean actually in astronomy or
in reality there is nothing called complete inductive proof. You cannot say
incomplete induction.
So incomplete induction, as per Karl Popper, it cannot be, and not only per Karl Popper, also the logicians, they agree on this. And this is why they are very fond of, many of them are very fond of deduction, because deduction is easier. You have a general rule, and then you have a part of this rule, and then you deduce. But for Karl Popper, it's not like this at all, because this is not the way physics works. Actually, we'll be seeing here.
It starts from the particulars.
So there is the existence of falsification, and the existence of a proper formalization is also a requirement and demarcation criteria. So you need a precise meaning for symbols, and you need to generalize, and then you have a formal language versus a formal semantic model. So you have a sentence, which is actually a set of symbols, and these symbols have a meaning which you define somewhere else in a very precise way also. So you make a distinction between your symbols in the formal language, your sentences, and what they mean. Now, I
think this is the core of programming, if I'm not mistaken.
No, let's not be very hasty, but
okay,
of course, it is the core of programming, of course. And here lies everything between. I mean, the whole of computer science and even epistemology is between those two aspects: the syntax and the semantics. So actually, everything you can read, any problem in computational symbolics is actually a problem of relating your sentence with the semantic which you would like. Any problem is like this.
And we have example, a physical law.
We have here the example, a physical law. What is a physical law? Like I have a law, for example, gravitational law. What is a gravitational law? It's an informed guess inferred using incomplete induction. Here we find again incomplete induction. It is general enough to have consequences, Because any law must be general also at the same time, and it is experimentally falsifiable. And by the way, those three requirements, they don't come from Popper, but from Feynman. Actually, from what Feynman considers to be a physical law. So it is an informed guess, inferred using incomplete induction. So you have done a lot of experiments, and then you sit around and then you think about the results of those experiments, and then you generalize your findings in a certain informed way. So if I don't,
and this is the meaning. Why this is the meaning of the relativity of science, of human knowledge.
we will come to this, but for now, it fulfills this physical law fulfills the demarcation criteria. Why? Because I have a set of experiments and I use incomplete induction. I generalize, and then it is experimentally falsifiable. So it fulfills exactly what Popper wants. Now, there is also the question causality and determinism in scientific law. Of course, laws are based upon the idea of cause and effect. If you say law, then there has to be cause and effect. And this implies actually determinism, i.e., the necessity of the implication relation. If I say A implies B, for example, my law is saying A implies B. What do I mean from the scientific point of view of A implies B? That whenever there is A, there must be B. So there is something like a necessity in the implication relation. Of course, this was all the time for millennia. The people thought that this necessity, this determinism, must.
I think this is still Newton.
This is through Newton also, but modern physics has shown that causality is only locally possible.
Yeah, like Max Planck and Einstein.
No, maybe let me explain this. What's the meaning of local causality? Local causality means that causality within, for example, the solar system is possible, but cannot say, I mean, this necessity of causality is only possible within the solar system. Why? Because if I say the relation is also right throughout the whole universe, then how can the effect, the cause and effect relate to each other if I need billions and millions of light years for a cause to find an effect? You got me? Yani what I'm if you do the modern physics, you know this thing of that the speed of light is the maximum speed. So if I am here on Earth and at the end of the universe there is, so if I have, for example, here I have the cause here, and at the end of the universe the effect should come. It cannot come because of the speed of light. It should travel. So cause and effect are only locally possible, where the speed of light doesn't play a role. And this was proven by an experiment, the so-called Bell experiment. Shows you that local causality is the only way you can explain this Bell experiment. But so what I'm here trying to say that causality and determinism come hand in hand with the law, and everybody was thinking causality and determinism come together until the modern physics showed the contrary. Now here it's interesting to compare this to Al-Ghazali. I compare this Ghazali and Ibn Rushd. While Ibn Rushd, Averroes, was all the time claiming, and of course it is very clear why, because he was Aristotelian actually, that causality and determinism must go hand in hand. Al-Ghazali doesn't consider the cause and effect to be really necessarily binded together. Yeah. So there are now, of course, objections to Popper. Quine objected
so Al-Ghazali reached to this conclusion before Hume, I think, if I'm not mistaken.
Before everybody. So he He reached this conclusion hundreds of years ago,
Yeah,
and from the pure
at least
Islamic
6 centuries before the
from the pure Islamic
time.
point of view,
Mm.
he was in his book, in his very famous book, Critique of the Philosophy, he very clearly states that from the pure Islamic view, the only real cause, al-illah, the only real cause for anything is Allah Himself.
It's good. Yeah.
There is no material cause of anything.
Mm.
From this point of view, he refused to say that if I say to take cause and effect as necessarily binding each other. Yeah, so it and explicitly he states that there might be some causes which like for example, if I get a piece of cotton and put it near to the fire,
Mm.
as per cause and effect, it must actually as
Mm.
per everybody else, as per this determinism, it
Mm.
must burn. But Imam Ghazali says no, it might be the case that it doesn't burn. So
Mm.
there is no, I cannot say that fire is the cause of burning
And I
cotton.
think now quantum physics can give us
No, but
yeah.
what I'm trying to say that he shattered at that time. He shattered this belief in the necessity of cause and effect,
Mm.
and he was criticized by everybody for doing it, and especially by Averroes, Ibn Rushd, who was really very angry of him. When you
Yeah.
read what he wrote about
تهافت
Al-Ghazali, yes,
التهافت. In his book, the incoherence of the
exactly.
incoherence. Yeah.
But we know now that he was right from the
Mm.
epistemological point of view. Now, there are some objections to falsification, notably by Quine. And Quine objected to Popper by saying that we don't only falsify one theory. Actually, there is nothing like only one theory. When we say A implies B, we don't really only say A implies B. We have a set of a web of beliefs, like he called it, a web of other beliefs behind this A implies B. For
Mm.
example, A might be bacteria
Mm.
or whatever. So we have some very specific notion of bacteria in our mind when we say bacteria implies illness or bacteria implies cold. Yeah, the illness of cold. When I say illness of cold, I have also a web of belief in my head behind this
Mm.
terminology. So actually, you are not falsifying A implies B. You are falsifying a list of conditions, and then the question poses itself: which one of these conditions failed?
Mm.
And if I say if I say, for example, A implies B, but for this rule to be true, A must also imply D and F and all this. When I falsify this, when an experiment falsifies this, then then the question is which one of these beliefs were falsified. It's not evident that I only falsified A implies B. Yeah.
Yes, it's clear. Yeah.
So this was his objection. So he's actually saying that it is not practical. What Popper is saying is not practical because you don't falsify only one theory, but you falsify the conditions behind it. You falsify the terminological understanding of things and all this. Now, in modern epistemology, Western epistemology, you have only two levels of certainty, actually. Either you know something or you believe in it.
Mm.
In between, there are many things, but they were not really formalized in modern epistemology,
Mm.
especially in logics. They were not formalized appropriately in logics. Actually, modern logics is the one who attempted to formalize knowledge and belief, but there are many critical points which were not solved in this logics.
Mm.
So this is a setting of. So we'll maybe, do we have time?
I think we have 4 minutes. So yeah.
Yeah, maybe we take the working example.
Yeah.
The working example is a very simple one, just to make the things more related to reality. Let us say I am Colombo. You know Colombo, the
respect.
the famous, So and Colombo finds a man who is stabbed and the footprints of a man near the body. So Colombo comes to the sign of the crime, the scene of the crime, and he finds a man is stabbed and there are footprints of a man near the body. And although the man had a lot of money on him, nothing was stolen. Now, of course, Colombo could do any other research and will do normally Colombo does very detailed research, but in the beginning, there might be some three possible hypotheses. One is that a male acquaintance of the victim killed him. So a male killed him, and because the footprints are footprints of a man, so it's maybe nearer to assume that a male acquaintance of the victim killed him. A female acquaintance of the victim killed him, and she wanted to frame, of course, someone else. This is also possible. Or C, a complete stranger killed him. Now, we have now these three hypotheses. The question is, which hypothesis is scientific and why? We're applying now the ideas. Maybe you should tell me before I show you the result. Which hypothesis is scientific and why, Ahmed? Applying now what we knew before in the last slide about the demarcation of between science and what is it?
He has to prove that the footprints of the is a male footprints, not a female footprints. First of all, this is
no, it's a male. It's a male. It's a male. It's a male. It's a clear.
So he has to prove that a female that wore a shoe.
No, the question is which one of these is scientific and which one is pseudoscientific. Let us concentrate on pseudoscientific. Which one of this is pseudoscientific?
I think the second one.
After Popper, If we take Popper, what is the most important thing which Popper considers?
Falsifiability.
Falsifiability, exactly. Now think about them in terms of falsifiability.
So the man.
Let me help you a little. A is scientific. Why? Because it's coherent with evidence and can be falsified by checking solid alibis of male friends. He will, because A says that a male acquaintance, so somebody who is a friend or somebody who knows the victim, so he get everybody who knows the victim and check the alibis.
That he was absent.
If they were all not. If they all have alibis, then this is not. It is scientific, but it is not coherent with evidence.
I think we have to leave it here with Colombo, and in the next part, we will delve more in the slides and to know more about your project. So thank you very much for this first episode in this podcast, and God willing, we will go further to discuss more topics in the coming part.